Hi guys. Okay, so let's look at chapter 7, chemical reactions. So first of all, we will look at writing the chemical equations or writing the chemical reaction. So this is actually the language of chemistry. You will look at balancing the equations and the types of chemical reactions. So in this lecture, we will only talk about combination, decomposition, replacement, and combustion. And then there are others also, which is the redox reaction, and then the exothermic and endothermic reaction, which I'm going to do it in the next video. So first of all, when we talk about writing a chemical reaction, what does this mean? Writing a chemical reaction. Okay, so you have seen that when two things react, they produce a new substance, okay? And that new substance has its own qualities. So we express this in our language. For example, you have sodium, which is solid, okay? And it's very reactive and it's flammable, and that's why we put it under oil. This reacts with chlorine. Chlorine is a gas, okay? A totally different, set of properties. So when sodium and chlorine react together, they form sodium chloride. It is our common salt you see on the table, okay? And that is a solid. So sodium, which is poisonous, which is highly reactive, which is kept under the oil, and chlorine, which is in a gaseous state, they produce a new substance, which is not toxic, is not flammable, and it is kept on the tables, so it survives. It doesn't react with anything, but it provides us a nice, taste, salty taste. So that is what it is. But there's also something that we do when we write the chemical reaction is we see, are the total number of atoms reacting in the right proportion? So that ratio in which the atoms react, that depends on their chemical reactivity. And the chemical reactivity comes from valence, or the valence electrons. Okay, so here we see that 2 atoms of chlorine are reacting, but only one of them is combining with sodium. So therefore we balance it. So here this 2 applies to sodium and this 2 applies to chlorine. Okay, and I'm going to talk more about balancing later, but just to give you an introduction. So that 2 we put in front, that is called coefficient. Coefficient. And this coefficient applies to both the atoms, sodium atom and chlorine atom. So now we have 2 chlorine atoms and 2 sodium atoms combining together. But on the other side, we see there's only 1 sodium atom. So we balance it. We bring two atoms, so two sodium atoms, and this 2 applies to chlorine. So this means 2 atoms of sodium reacting with 2 atoms of chlorine. And that's giving you, and I'm going to just erase this, and that's giving you 2 atoms of sodium combined with 2 atoms of chlorine. Okay, it's as 2 atoms of chlorine, and together they make NaCl. Okay, so NaCl, and then the 2, like we said, let me just put it here. This is coefficient. This is called coefficient. Okay, now this is the way we talk about chemistry. So it is a shorthand, the language of chemistry. So this is how you write a chemical reaction. Similarly, so first of all, when we talk about a chemical reaction, what are the things that define a chemical reaction? How do you know that a chemical reaction has occurred? So anytime a chemical reaction has occurred, that means this is a permanent change. A new substance is formed, and the older substance, the substances that are reacting have lost their properties. So permanent change, and this is a new substance with new set of property, a new substance, new properties, new set of properties are formed. Okay, then you will hear if a gas is formed, then there is bubbling, there is fizzing sound. So that's the fizzing, you can miss it. There's a fizzing sound, bubbling. You would also see fumes coming out if a gas is formed. If a solid is formed, then in that case, you will see a precipitate, Precipitate. Now, what is a precipitate? Precipitate is, see, that's a test tube. Inside a test tube, you would see the solid, sorry, let's get a different color. A solid either sitting at the bottom or suspended in the middle, like a solid suspension, or it's like, big particles, like a milky solution, turbidity, so like that. So we would see that in the solutions, in the reaction solutions, if the solid is suspended or sitting or floating, all that is considered to be, so let's just get this here, all that is solid precipitate formation, a new substance. Okay, sometimes there is a heat exchange. Heat either is evolved or is taken in during a chemical reaction. So when the heat is taken in, then if you touch the test tube feels cold. Test tube feels cold, and when you take the heat is absorbed, taken in is absorbed, or the heat is given away. And when the heat is given away, that means that the test tube feels hot. Test tube feels hot. Okay, that thing. Next is the sometimes you may just see a color change. You may see a color change, or you may not see a color change. So it's not like all the time it's color changes, permanent change, but it is still like something has happened. Okay, so this is how the basic things about, this is a basic introduction of writing a chemical reaction or what a chemical change is. So it is a language of chemistry. Okay, now this is all this, when we write a chemical reaction, this is based on the law, which is the law of conservation of matter, law of conservation of matter. Now, what does this mean? Conservation of matter. Conservation of matter means that the matter cannot be created. You cannot create matter from your side, like produce like totally something out of the blue. You can't do that. So matter, it's not possible. Matter cannot be created, at least not by, us humans, cannot be created. Matter cannot be destroyed. Okay, matter cannot be destroyed, but matter is transformed. Matter is transformed from one form to another, from one form to another. Okay, so when we say that one form to another, that is what we see. Matter is transformed from a solid state. This is a matter, a solid state and a gaseous state combined together, and they produce a totally different solid state. So in this case, the total matter remains conserved. Now, what does this mean? Conservation of matter. So let us say, for example, take another example. Here you have sulfur. Sulfur is a solid, yellow colored like a rock. When it combines with oxygen, okay, and oxygen is a gas, and it gives you sulfur dioxide, okay, and sulfur dioxide is a gas. All right. Now here, what this means is that this means one atom of sulfur, and later on you're going to see that it's not even the atom, it's actually the moles. But when we're balancing equations, it's okay to for now say it. So one atom of sulfur, this 2 applies to oxygen, so 2 atoms of oxygen, okay, oxygen, they when they combine together, they give you one atom of sulfur and 2 atoms of oxygen. And then when all of this combines together, this is 3 total atoms combined together in a definite ratio. So this is in a very specific, in a definite, DEFINITE, in a very definite proportion or a definite ratio, and that is 1:2 ratio. Only not 1:3. 1:3 would be a totally different substance. And 1:4, totally different. 1:5 will not happen. 1:6 is not happen. 1:1 is not going to happen. So it's only 1:2 ratio. Okay, so 1 atom of sulfur and 2 atoms of oxygens. When they combine together, then they produce sulfur dioxide. And this is stable. This is actually a stable molecule. Stable molecule. That's another thing. You know, it should be. This is a molecule. So it's in that stable is only when this definite ratio is attained. So like I said, if it's not 1:2, it's something else, then it's not the same species. Now let's look at the masses. So sulfur, what is the mass number of sulfur? Look at that, mass number of oxygen. Here, the mass number of sulfur and oxygen. So 2 of oxygens and 1 of sulfur and 2 of oxygens. Okay, so sulfur is, the mass number of sulfur is 32, as you can see. So sulfur is 32, and okay, so let's look at the mass number. So sulfur, 1 of sulfur times 32, okay, and 2 of oxygens times 16, then 1 of sulfur times 32, and 2 of oxygens times 16. So what do you get? So this is 32 coming from here. This is 32 coming from here. So this is going to give you 32, and this is giving you 32. This is also giving you 32, and this is 16 twos are oxygen, the mass number of oxygen is also 2 oxygen, 16 times 2, 32. So you add these two, What do you get here? This is 64 weight, and this one is also 64. So you see the total weight on the reactant side, the weight that is coming in this reaction from the reactants is equal to the weights on the product side. So always these reactions are written in a way that the reactants are written on the left-hand side, always, and the products are written on the right-hand side. And the weights of those have to be the same in order for the reaction to actually work. Okay, so you see that is the law of conservation of matter or mass. The total mass remains the same. So it doesn't become 33 also, it doesn't become 31, it's always same, okay, in this case. All right, so let's look at now a few examples, and then we will look at the balancing and the types of reactions. I'm going to all combine them actually. So, for example, look at this. Yeah, I'm going to just combine. This is a balance the following chemical reactions, and then, okay. All right, let's look at, first of all, balancing. Balance. Okay, so balancing chemical reactions, and let's look at the type of reactions also at the same time. So I'm going to merge the two things together. So it's like we will have to continue. Balancing is a continuous process. So types of reactions is all merged in one, like sections. So instead of breaking them up into different sections, like doing them again and again, I'm going to just, so basically, as we talked about, that when we balance the chemical reactions, we see that the total mass is the same. That means the total number of atoms should be the same on both the sides. Okay, so balancing chemical equations of polyatomic ions, yeah, types of reactions. So first of all, let's look at the types of reactions. We will look at number one, combination reaction. These are the simple reactions, combination. When we, so I'm going to say these are in same sections. Okay, so first is, this is one section here, which is the combination reaction. Okay, combination is common, like it's a generalized thing, which means that when you take A as a reactant and you take B as another reactant, they are going to produce AB. This is that simple. Okay, so for example, the sulfur dioxide we did, and we are going to look at more. For example, a simple combination reactions is like, for example, here is copper, okay, reacting with copper as a solid, and you have sulfur also as a solid, and you heat the two together, they are going to produce copper sulfide. Okay, so this is called copper. The names and the symbols are important. Copper sulfide. Okay, this is one simple. So here you see one atom of copper. Now, instead of writing atom all the time, I'm going to just put like this: one atom of copper, one atom of sulfur are giving you, this is copper, actually 2-sulfide. Copper 2-sulfide. Okay, so copper and sulfur. Okay. All right, so here, and this is also a solid. So here also we see one atom of copper is fused with one atom of sulfur, and this is a stable molecule. So we see on either sides 1, 1, 1, and 1 balanced. Okay, now let's look at another example. Another example is, you have magnesium, okay, as a solid reacting with oxygen as a gas, gives you magnesium oxide as a solid. Okay, now here you see there is one atom of magnesium. And remember, this 2 applies to oxygen, so there are 2 atoms of oxygen. And there is one atom of magnesium here and one atom of oxygen here. All right. So what happens in this case? In this case, we see that oxygens are not balanced. So we have to do something about it. So what we do is, in order to balance oxygen, you put 2 in front. That means 2 applies to magnesium, 2 applies to this oxygen. That means 2 times 1 magnesium and 2 times 1 oxygen. Now it gives you 2 magnesiums and it gives you 2 oxygens. So now we see that by doing that, we see the oxygens are balanced. But something that got ticked was magnesium. Magnesium is 2 on this side, magnesium is 1 on this side. So what do? We are going to take 2 times magnesium, and that is 2 magnesium. Okay, so you put 2 here. So this 2 applies to magnesium. So that makes the magnesium 2. That makes magnesium 2. So now we see that there are 2 magnesiums on both the sides and 2 oxygens on both the sides. And it's always important to check for balancing. So 2 magnesiums, 2 oxygens, 2 magnesiums, 2 oxygens, balanced. Okay, so this is a simple combination reaction. Let's look at one more example in which, so this was adding 2, which is simple. Now, in case there are, like for example, nitrogen as a gas reacting with hydrogen as a gas, and this gives you NH3 and H3 as a gas. Okay. Now we have nitrogen as a gas and hydrogen as a gas gives you ammonia. So what do we see here? We see that there are 2 nitrogen atoms, 2 hydrogen atoms. They are chemically combined in the ratio 1:3, and that 1:3 ratio is only going to produce ammonia, which is a stable molecule. Okay, but if it is 1:4, it will be a different molecule. 1:2 is not going to work. 1:1 is not going to work. It's not stable, right? So it's very important that whenever the new substance is formed, then that is the chemical reaction is to produce a permanent change that is stable product, right? And if the product is not stable, then the reaction continues to go in order till it gets a stable product. Okay, so here, and that stable product, like we said, is always in a let me just put this here, stability is achieved in a definite ratios, reactants combine. Okay, so it's not like, just mix things. It's not like a mixture. Okay, so anyways, so here we have 1 nitrogen and we have 3 hydrogens. Okay, so obviously you see that most important thing is that the hydrogens are not balanced. So 3 hydrogens on one side and 2 on the other side. And we also see that the nitrogen is not balanced, 1 here and 2 here. So what happens now? So we are going to take the hydrogens to balance. So look for the common multiple. And the common multiple is 2 times 3 is equal to 6, and 3 times 2 is equal to 6. Okay, so 3, you put 3 here and you put 2 here. So this 3 applies to hydrogen. You put 2 here because you wanted to change hydrogen, but then it also applies to nitrogen. So 2 times nitrogen and 2 times hydrogen. So here, 2 times nitrogen is 2 times 1 nitrogen is 2 nitrogens. 2 times 3 hydrogen is 6 hydrogens. And you have 3 times 2 hydrogens is 6 hydrogens. Okay. So now what is not balanced? So we see there are 6 hydrogens, which is a good thing, but and what about the nitrogen? So there are 2 nitrogens on both the sides, and we have 6 hydrogens here and 6 hydrogens here. So we have 2 nitrogens, 6 hydrogens. Okay, so that's all balanced. And when you do the weight, let's just for the fun, let's just do the weight. So we have 2 times nitrogen is 14.0. That's the mass. Masses are also the same. Masses on the product side and the reactant side. Sorry. The masses on the reactant side is equal to the masses on the product side. Total mass. Okay. Let's just here. Total mass on the reactant side is equal to the total mass on the product side. Same. Okay. All right. So let's look at this, the masses. So we have 2 nitrogens. So we have 2 times 14 for the nitrogen. So that becomes 28 grams is coming from the nitrogen, and 6 hydrogens. So we have 6 hydrogen is 6. Let's put this way, 2 nitrogens and 6 hydrogens times 1 gram from hydrogen. So 6 grams is coming from hydrogen. So 28 grams coming from nitrogen, 6 grams coming from hydrogen. You add the two together, 28, 34 grams total. 34 grams on the reactant side. Okay. And the product side is, so now we have 2 nitrogens, each is 14 grams, right? Plus we have 6 hydrogen, each is 1 gram. So again, we have 28 grams coming from the nitrogen on the product side and 6 grams coming from the hydrogen in the product on the product side. Okay, so the total weight is the same on both the sides when you balance it. All right. Okay, next look at this was, and so many other combination reactions. Pretty much you will be just doing the balancing the same way. Next, look at the decomposition reaction. Decomposition reaction. Now, decomposition reaction, decompose, you know, when things begin to decay, decompose. So how does this occur? So this is, so you have AB breaking up into its components. For example, A and B. Okay. Now let's look at this type of decomposition reaction. For example, you have calcium carbonate, CaCO3 as a solid. When you heat it, okay, when you heat this. So heating is shown like this type of a symbol. So when you heat it, this gives you calcium oxide, which is a solid, and it releases carbon dioxide gas as fumes. Okay, so now let's look at the total number of hydrogen, the balancing. So 1 calcium, 3 oxygens, 1 calcium, 1 oxygen, 1 carbon, and 2 oxygens. Okay, so we have a total of 2 plus 1. That makes a total of 3. So this is 2. So 2 plus 1 plus 2 is equal to 3 oxygens. So 1 oxygen and 2 oxygen give you 3 oxygens on the reactant side. And on the product side, there are 3 oxygens. So this is, sorry, on the reactant side are the 3 oxygens, sorry, and the product side are the 3 oxygens. So that balances it. Okay, so this is the product side. Then you have calcium and calcium 1. Okay, 3 and 3, that's balanced. Okay, so this is one piece. Next is, let's look at another example of decomposition. For example, KClO3, and this thing, when you heat it, this gives you KCl plus oxygen. Okay, KCl is solid, oxygen is a gas, and this is a solid. All right, so now what do you get? We have now okay, yeah, so let's see. So we have 1 potassium, we have 1 chlorine, we have 3 oxygens. Here we have 1 potassium, we have 1 chlorine, and we have only 2 oxygens. So clearly we see that oxygens are not balanced, but potassium and chlorines are balanced. So in order to balance the oxygen, we will have to make some change. So we are going to, because this is 2 and this is 3, and in order to equalize them, we will now have to look for a common multiple, and the common multiple is 2. So 2 times 3 is equal to 3, and here the common multiple is 3. So 3 times like 2 oxygens is equal to 6 oxygens. So now we have 6 oxygens on both the sides. So common multiple is 6. Sorry, common multiple is 6, but 3 times 2 and 2 times 3 makes that balance. Next is potassium. Now remember that this 2 applies to potassium and this 2 applies to chlorine. And yes, this coefficient applies to oxygen. So the whole idea was to balance the oxygen, but it tips the scale. So it's just like you balance food in the grocery stores, right? So you sometimes you have to like balance the scale, you remove things, you add things, you remove things. So those things, same way you're doing that. So now you will have to do this to change this. So now potassium becomes 2 and chlorine also becomes 2. Here, then you will have to balance it. So bring 2 here in front of potassium and chlorine, because now you are changing this so you can balance the potassium and chlorine. So here you will have potassium chlorate, that's the name, potassium chlorate. So this is another thing, you know, for balancing equations, you should really know the names of the compounds, names of the molecules, ionic compounds, those things. And this is potassium chloride, potassium chloride. And of course, oxygen gas. So that's important, okay? So now we see that the potassium oxygens are balanced, and we also see that potassium is 2 potassiums here, 2 potassiums here, 2 chlorines here, 2 chlorines here. So all this is balanced. So this is this and this, this and this, this and this balanced. All right, now you take the third part. So that was the decomposition. Okay, so let's look at now, move further. We will have now replacement reactions. Okay, now when we talk about replacement reactions, there are 2 types. One is the, so this is the third one, is the replacement. Okay, ideally, you know, we go in more detail here regarding the, you know, there are 2 types here. One of them is the single, now replacement, this also means displacement. It means the same thing. This also means displacement, displace, so interchangeable, it means the same thing. Okay. Now, there are 2 types. One is single displacement, and the other is double displacement, single and double. Now, single displacement and double displacement are double displacement. Now, we're going to look more into details later, because double displacement deals with the, here's the thing, single displacement, you are going to use the activity series, which one displaces which element. But for now, you know, this is just a basic thing they have given you in your book. They have not mentioned that. And since this is an online class, so I'm going to, I don't want to like introduce too many details if they're not specifically explained in the book for now. However, there are videos on these, which I have posted separately. So I highly encourage that you watch these videos also. So videos, watch these videos on very specifically on the activity series and solubility tables. So solubility, we will cover in the chapter 9 on the solutions. So we will cover this more detail. So chapter 9 on the solutions chapter. So we will cover the solubility there. But you are welcome to watch the videos on these, how to use the activity series to determine whether a single displacement reaction is going to work or not. And then how to use the solubility table to determine whether the double displacement reaction is going to produce a solid or not, or gas or not, you know, those things. So those details we will cover later. For now, it's okay to watch the videos, and if you understand, good. If you don't, as far as you learn how to balance them, that is more important. Okay, so let's look at now these type of reactions. A single displacement reaction. So a single displacement means, so single displacement reaction. Okay, single displacement means that when one atom displaces the other from the bonded state. So for example, magnesium. When magnesium is a solid, when it reacts with HCl, aqueous acid, then it makes magnesium MgCl2, and it releases the hydrogen gas. Okay, and again, it all depends on the activity series, whether magnesium will do that or not, or what, you know, whether if it's not magnesium, if it's some other element. So just keep this in mind, that copper, mercury from the activity series. Let me just put this here. Copper, mercury, silver, platinum, and gold, Au, gold, will not react with acid. Au will not react with acids. Okay, the rest of the others will. So that's what I meant to say. So here we see that hydrogen, now here we have magnesium reacting with HCl. So it breaks the bond between hydrogen and chlorine. Okay, so that bond, magnesium has the power because magnesium is above hydrogen in activity series. So in other words, magnesium will react with acids. So here, when it replaces the hydrogen and it replaces the chlorine, then what happens? Then the chlorine reacts with magnesium to produce magnesium chloride. But keep this in mind that this 2 applies only to magnesium, sorry, to chlorine, and this hydrogen 2 applies to, this 2 applies to hydrogen. So what do you get here? We are going to now see that there are 2 chlorines and there are 2 hydrogens. Okay, and there is 1 magnesium, 1 of magnesium. Okay, on the reactant, on the product side. And then on the reactant side, yes, there is 1 magnesium and there is 1 hydrogen and there is 1 chlorine. Okay, 1 chlorine. So then what happens? So let's just remove that. 1 chlorine, 1 hydrogen and 1 chlorine. So in that case, we need to balance the chlorines and the hydrogen. So what do? You put 2 here in front. So this makes 2 hydrogens and 2 chlorines. So 2 times 1 hydrogen is 2 hydrogens, and okay, so 2 and 2 times 1 hydrogen is equal to 2 hydrogens, and 2 times 1 chlorine is equal to 2 chlorines. Okay, so what do we see here? 1 magnesium, 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. All right. So we see that this is how all this is balanced. So that is a single displacement. Another single displacement is, for example, you have so this is one example, and this is another example. So we have copper reacting as a solid with silver nitrate, AgNO3. Okay, so AgNO3. So what copper does? Copper breaks the bond between silver and the nitrate ions. So nitrate ion is one entity, one species by itself. So this gives you copper nitrate, Cu NO3 and silver. Okay, it releases the silver and it combines when it breaks the bond. So if you look at the overall balancing, so you have one copper reacting with one silver. Now keep the polyatomic ions intact for the most part. If the polyatomic, now please note here, please note that if polyatomic ions are the same on reactants and product side in a reaction, then count them as an entity. Like, don't break them. I mean, you can, if you want to, count them as an entity. In other words, do not break them. Do not break into atoms. Like, if you want to, you can, but generally, you know, they're seen as one. So here we have silver is one and one nitrate. That's what I mean to say, as one nitrate. So example is nitrate. So if nitrate is not breaking up into if nitrate is not breaking up into nitrogen and oxygen or nitrogen dioxide or something else, then just leave it as one. So we see that this side also, there is one nitrate and one oxygen, one copper and one silver. Okay, so we see copper one, we see silver one and silver one, and we see the nitrate as one and nitrate as one. Okay, so that balances the whole thing. So this is what a single displacement reaction is. Okay, and so if you have to balance it, you balance it. Let's look at the double displacement now. And we will cover more examples later if it's needed, but we need to keep going. So double displacement. Actually, here's the thing. I'm going to hold on to double displacement because I have to start my office hours. So here is the double. I'm going to just make a note here. Double displacement. And combustion to be continued. Okay, in my next video. Okay, all right, so hold on to this. So this week all we are doing is these reactions, and then the next week is going to be the stoichiometry. So we have time. All right, guys, so hold on to it. And meanwhile, you guys should watch the videos which I have already posted, as those small videos give you a more focused, you know, look. All right, thank you so much. And if you have any questions, feel free to put your questions in the you know, in the either under the announcement, or you can just send me in the inbox. Okay, thank you. Bye-bye.